Okay, good day and welcome. We will be looking at trigonometric equations, right? And I put this little meme here because the objective here is to get rid of the trigonometric ratios, and there is only one way to get rid of them. It's not by multiplying or dividing or adding or subtracting, but it's rather by using the inverses. Okay, so the inverse of sine is sine. That's a little bigger than expected, so let me fix that. Let's go to 2. So the inverse of sine would be sine raised to the negative 1. Okay? The inverse of cos would be cosine raised to the negative 1. And the inverse of tan would be tan raised to the negative 1. So if you ever want to get rid of either one of these guys, this is the only way to do that. Okay, and I want to quickly just explain to you why it works out, right? So you have sine, and then I'm telling you, multiply it by sine negative 1, right? That means you're taking sine over 1, and you're multiplying it by 1 over sine, right? And now at this point, you can kind of see that this will give you, if you multiply top with top and bottom with bottom, you get sine over sine, which will give you 1. So that gets rid of sine. Okay, so that is the only way to get rid of sine, cosine, and tangent. If you have sec, if you have cosec, if you have cot, right, you need to first write them in terms of the ratios that you know. Because there is no sec negative 1, cosec negative 1, cot negative 1. You must use sine, cos, and tan only. Okay, so let's get into the examples. Okay, so first up we have sine x equals a half. We need to solve for x. Okay, so what we're doing is we are saying sine raised to the negative 1 exponent multiplied by sine x, and we do it on both sides, is equal to sine raised to the negative 1 multiplied by a half. Okay, now the step where you write this portion in over here, this is not necessary to do. You can just do it on the one side. Okay, so sine negative 1 and sine will cancel to become 1. So then we find out that x is equal to, you take your calculator, you type in shift sine 1 over 2, and you get 30. So the angle is 30 degrees. Okay, and that is it. Easy peasy lemon squeezy. Okay, so example 2 says that 4 multiplied by the cosine of x is equal to 3. Now let's look at where x is placed. X is all the way on the right hand side, and in the way is the cosine, which is attached to x, and then we also have 4 that is in our way. Now between the 4 and the cosine of x, the 4 is furthest away from the angle, right? So we need to first get rid of the 4 just like we would in any other equation. So what I'm going to do is I'm going to divide both sides by 4, okay? So that would mean that I end up with cosine x equal to 3/4, okay? Divide both sides by 4, and this is what I get. At this point, you do this just like the previous example. We multiply both sides by cosine raised to the negative exponent, right? So on the left-hand side, we won't write it out, but we know that that is how we got rid of cosine. So I say that x is therefore equal to cosine raised to the negative exponent multiplied by 3/4, okay? And then we go to our calculator and we say shift cos 3 over 4, close that bracket, and it tells us that the angle here is 41, comma 409. I would like us to round this off to 2 decimal places, so this angle is 41, comma 41 degrees. Okay, if you want to check that your answer is in fact correct, you can go ahead and substitute 41.41 into this equation. Okay, I'll type it in on my calculator. So we say 4 cosine 41.41, and I get an answer of 2.9998255. So this solution is in fact the correct solution for our equation.